Hello students, in this video we will talk about electromagnets and its uses. So students, in previous video lectures I have explained all types of magnets and the magnetic field lines, how earth magnetism, all the main topics from this chapter magnetism I have explained. And today what topic we just explained, that electromagnet, it is very it's very easy. Also you can you are well known about the electromagnets from very junior classes. Okay, in previous classes you have the idea. So students, little bit more knowledge you will gain here, that how a electromagnet will form. Okay, so that's why this lecture is important. So here first there is a definition. An electromagnet is a temporary strong magnet. So I told you it is a temporary magnet and made of a piece of soft iron. Soft iron basically used, means mainly soft iron is used for electromagnet purpose, and steel and other materials still used for permanent magnet. These are important, students. Sometimes question used to come. So if you magnetized a steel, means if you wound a wire around a steel and provide electricity, then what happen? It will convert it into permanent magnet. Whereas if you use a soft iron bar, it has the property, means when you just switch on the electricity, it becomes magnet, and when just you off it, immediately the magnetism vanished. Okay, means that magnetic property also on and off with the switch on and off of the electricity, when the electricity pass and when the electricity not passed. Okay, so this is the thing, difference between permanent magnet and electromagnet. So some materials also used, hence this purpose is specific. Okay, not all the materials, all the elements can behave like a electromagnet. Basically soft iron. Okay, so just remember this thing, that's why it has specially mentioned over here. So a piece of soft iron, when current flows in the coil wound around it, it is an artificial magnet. Okay, so I hope you got the sense, you get a sense. So here it is. So an electromagnet can be any type. So generally there is two shape explained here: I shape or bar magnet, U shape or horseshoe magnet. So how a bar magnet, means I-shaped magnet generally act like electromagnet, which is I-shaped. Generally, its acting capability just like a bar magnet. That's why it has written over here. Okay, but it is a electromagnet. You need to remember, as soon as you just turn off the electricity, its magnetic property will be vanished. Okay, so construction of I-shaped electromagnet here, basically, if you turn the page, here it has present, you can see. Suppose I am saying, explaining here, there is a nail. If you read nail or any type of soft iron rod you can take. Suppose I am drawing here by using a nail. Suppose a nail you have taken, okay, and just make a loop around it. Okay, and here this is the this is loop, means a wire, insulated copper wire. 1 minute, yes, insulated wire, turn over the soft iron rod. Okay, and hence when you just add battery, okay, battery both pole, when you just attached with the two sides of the wire, insulated wire, what happens, students? Then a complete circuit will be there. As you complete the circuit, okay, here the switch, everything has given over here. So no basically more properly here it has explained. You can see there is a switch. When you just turn on the switch, then the electricity will provide. So no problem, students, you can easily understand how there you can attach. Suppose in this position it cut and there is a switch like this. When you just attach, the electricity will provide, means will run the electricity, and when off, it will not undergo. Okay, so I hope you can understanding what do I mean. So very basic knowledge I am explaining. Okay, so when as soon as we attach the battery, what happened? The electricity will run through it. And students, as the electricity will run in between this coiled wire, it will generate a magnetic field. Okay, means it will act like a magnet when the electricity pass through the loop. Understand? And two pole will arise. You know that a magnet has a two pole, so it will act like a solenoid. Solenoid, in my video lecture I little bit I have given the idea. Okay, solenoid is a coiled wire. Okay, just like this. When electricity pass through this coiled loop wire, it will generate a electric field inside around the wire. So that is called solenoid. Means a solenoid also act like a bar magnet. Okay, so immediately when the electricity pass through it, and as the as it will a magnetic field will generate, that means two pole will be there. So how you will understand which side which pole arises? You know that in a magnet there is two poles, one is north, another is south. Now students, you have to look. If you look, I'm just deleting it, I'm drawing like this. Okay, then you can easily understand. Suppose this is a pin or a soft iron rod, and this is the, 1 minute, this is the wire, there is the battery source. Okay, immediately we have attached a battery over here. Now electricity will pass. Suppose from this side electricity pass, arrow. So if you look, if your eye will be here, eye, it's your eye. Okay, if your eye here, you can see that electricity pass, right, means clockwise from this side. If you look, you can see arrow. This is the arrow, clockwise. So clockwise means students, 1 minute. So clockwise means this is clockwise. See, just that is the S pole. Why? See, this is clockwise, you can see. Okay, clockwise means S pole. In earth magnetism, students, I have explained you also. Suppose this is earth pole. When from south pole, if you look, it is clockwise, and from north pole you can see earth is revolving. If you watch from the upper side, that is from north side, it is anti-clockwise, and if you look from the southwise, it is clockwise. So little bit I think you get an idea that when you see the electricity pass clockwise direction from one side, okay, that will be the south pole. Okay, from here also you can see clockwise means south pole. Okay, south pole means from this also, if you draw the picture of S, you can see that means a south pole, means clockwise direction it is showing. And similarly students, if you see the opposite side, means from this side, if your eye will be here, you can see means anti-clockwise. Just feel it, imagine it. Okay, from left side, from this side you see it clockwise, the turning is clockwise, and here anti-clockwise you can see, means like this. Okay, that means like this means if you draw in, see, you can see just it is showing like this, means anti-clockwise. So anti-clockwise rotation means there the pole will arise which called north pole. Okay, so dipole, how the dipole creation happens in a electromagnet, I think it's clear to you. Okay, as the wire wounded around the magnet, around the soft iron, so what happens, the direction of electricity will flow, current will flow from one side. If you watch clockwise, another side that is anti-clockwise, and the clockwise direction of the current flow, clockwise direction, that side is generated act as south pole, and anti-clockwise north pole. And by the figure, by the drawing the picture, you can understand north in. Okay, and in means anti-clockwise. Okay, so I hope students you can understand the which side about the pole and all the things in electromagnet. So this is the thing students. In case of horseshoe magnet also, when you will read, you can see, you will read. Okay, soft iron core. So here from this side, this turning how happens, how the turning occur, I am showing you. Suppose this is a soft iron core, you can see like this. turning. Okay, then 1 minute, then from this side. Okay, so like this. Okay, so here the electricity from that direction, you need to check the direction of electricity. Okay, any type, anyhow you can just rotate it, but the direction from this. So if your eye will be here, you can see clockwise direction. See, very easily you can understand that is clockwise. Okay, from this side you can see from here also. Okay, this direction means clockwise a rotation happens, clockwise. So clockwise means that is clockwise, south, hence there it is south pole. And similarly here you can see, I am deleting again, from this right side you can see the arrow is like this side means like this, understand, means left side arrow, left side means left side circular means the like this means anti-clockwise means north pole, you can see that is anti-clockwise. Okay, so similarly here also clockwise and anti-clockwise, from this flowing of current electricity will show you which pole will arise. Okay, as the bipole will creates in the soft iron core when the electricity pass, that means it will act like a electromagnet. Okay, means why electromagnet? Because if you use steel, student, in case of in place of soft iron core, here also soft iron core, suppose you are using steel, then it will be a permanent magnet, student. Okay, as we are reading electromagnet, so it should be soft iron bar. That's why it has written over here very properly, it has written soft iron bar. Okay, so I shape and U shape magnet. U shape means horseshoe magnet, generally it used in electric bell. Okay, the application we will read just after some time. So here it is, and way of increasing magnetic field in an electromagnet, that is how to increase the magnetic field. Students, first thing you know, by increasing the number of turn. If the turning, here you can say 1 2 3 4 5 turning, and if there it is 2 turning, then you can see here more magnetic field will arise, because turning is more turning means more polarity will create and more strength will be there. You know that if more turning will be there, so by this way we can create more strong, means we increase the magnetic field of an electromagnet, that is written here, by increasing the number of turns and increasing the current through the solenoid. Okay, so this is called solenoid. Solenoid is a loop just like this, turning wire. Okay, and when the electricity pass through the solenoid, it will generate the a magnetic, it will act like a magnet. Okay, now student, permanent magnet. A permanent magnet, naturally occurring magnet. Since here you know that a permanent magnet used in electric, this is important, used in electric meters, galvanometer, ammeter, voltmeter. Okay, and in magnetic compass. Okay, and here it does not lose the its magnetism easily, since steel has more magnetic retentivity than soft iron. Okay, as steel has more magnetic retention capability, that's why steel used as a permanent magnet. I hope students you can easily understand by reading these things. Here is the comparison. If you read, you can easily understand. And advantage of electromagnet over a permanent magnet. Here you can see electromagnet can produce a strong magnetic field. You know, electrical crane used to just unload the very big iron gadgets, you can say. That's why electromagnet is important. Permanent magnet has its importance from its own area. Similarly, electromagnets also has its importance from its different area. Okay, they are needed from their own respective working site. Okay, so here it is. Now here it is use of electromagnet. One use has given over here, that electric bell. It's, you can see you means horseshoe magnet is used over here, horseshoe type electromagnet. So I have explained already in class that the working of electromagnet in class 8 also it has present, so that's why I think you can easily understand. Students, you have to first look at the loop, means the wire, that red line, that red wire loop. Okay, you can see, students, when the battery attached, when the switch is on, okay, that electromagnet acts like a magnet. Okay, that is electromagnet, means when the electricity on, it will act like magnet, otherwise it is a normal iron rod. Okay, so as soon as the electricity will run, you can see it will attach the gong, means this. Okay, so when it will attach and immediately the electricity vanish, means it will just release the hammer. Okay, you can see, say this is the hammer. So that is the way, repeatedly, when it will electricity when pass through it, repeatedly it will attached with the magnet, and immediately when it will attached the magnet, when it's immediately the electricity pass through it, the circuit will be open. Okay, and as the circuit open, it's become normally again act like a iron, soft iron, then it will just move its own place. When it will move its own place, that time again circuit will close. So you just follow this circuit, students. I have explained in class 8 also, and I hope you can easily understand this thing. Electromagnet means this electric bell. Okay, so just read this thing, I think you can easily understand. Repeatedly that electromagnet and soft iron, it will just conversion happens, and in fraction of seconds several times these things happen. That's why this hammer will repeatedly just beat on this gong, and the sound will produce. Okay, so here it is, students, there is nothing more. That is the example 10b, that picture I will provide. I hope, students, you can understand. Thank you very much. That is the end of this lecture of this chapter, and next class we will go with the revision.